Hello everyone, now we'll study about the alkanes. What are the alkanes? Alkanes are the saturated hydrocarbons containing single bond between two carbon atoms like this CH3 and CH3. So it's usually like written in this way CH3, but actual bonding is like this. Somewhere you just see this form and somewhere you see just this form. So both are same things, but understanding should be clear. The bond between carbon carbon, not carbon hydrogen. It's if it's compounded written in this form, then you and then understanding will be clear in mind that it is obviously carbon and carbon bond. So next third point, homologous series member. C1 for the one carbon atom, its series is methane and its formula will be CH4 according to the formula use CnH2 and plus 2. If we put the 1 in place of carbon like just CnH2 and plus 2, if we place 1, so we will get C1H2 into 2 plus 2, it just we will get CH4. 1 should be written either yes or no. So in this form we can easily calculate the remaining formula. So CnH2n plus 2 and the methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane and decane. These 10 member, first 10 member of the homologous series you should know very well. So ethane, methane, C2H6 ethane, C3H8 propane and etc. going on by putting one by one this formula, you will get the required formula of the given compound. IUPAC nomenclature, we talk about the IUPAC nomenclature of that compound. Select the longest carbon chain for numbering the carbon atom. Branch group is treated as substituent. If an, okay, longest carbon chain should be selected. If the carbon numbering is just like this, and this, so and the carbon is written on here, so you should select from here 1 2 3 4 5 6 7 carbon, but you will take on this straight path 1 2 3 4 5. This will not be as accepted because we have to take a long carbon chain, either straight chain or from any round uh, numbering we are getting. So C1, C2, C3, C4, C5, C6 and C7, and why here is C1, C2, C3, C4, C5. That's not good enough. So for numbering will start from 1 2 3 4 5 6 and 7. This way you can take the longest carbon chain in any form, and whatever the branchings, firstly see this from branching the numbering is more or not. So, so select the branching, select the main chain or substituent branch chain very carefully. Next, branch chain group is treated as substituent. Only branch chain. For example, this carbon has should have hydrogen, so this is treated as substituent. Uh, the remaining part of the principal, except the principal chain. So third point, if any same substituent comes at same number of carbon atom, then it is written as twice as the carbon number. For example, 2,2-dimethyl propane. For example, if I take say this like this and same carbon is attached, then you will numbering it 2,2-dimethyl propane. I'm just writing the skeleton form of the molecule because it is understand. Then on the terminal position CH3 it is obviously attached, so it is no need to represent every time, and this one is also a CH3. So if the same substituent come at the same, so it will get 2,2-dimethyl. If the position like this, the C and CH2 and the CH and just like a CH3, if the position will be like this, so it will be treated as trimethyl and with the numbering. And if like this attached, so 1 2 3 4, so for 2 4 4 2 4 4 trimethyl. So numbering will be start from here 1 2, so 2 2 4 trimethyl, sorry, 224 trimethyl. It means for that numbering, we are numbering for that carbon atom, the numbering will be taken as twice if the two substituent is attached. If the same substituent attached other than that carbon, so it will be considered as tri. So if it is attached same carbon, it is di, and if it is attached along with same carbon to different carbon, it is a but having a same functional group, it is pronounced as 2,2,4 trimethyl methate probutane. So in this way you can easily uh, formulate any organic compound by its IUPAC name. So start next point is start the numbering from the nearby branching of the main principal chain. So always numbers start from the nearby branches, such as is this form is given, and next carbon is attached from here. So you will start from here, not on here, because numbering will start from the nearby branching chain. So this will be the basic IUPAC name, very common, you should know. So next we'll talk about orbital picture diagram. It is orbital picture diagram of ethane CCHH3 hydrogen attached. So when it is bonded with this sigma bond, this will form sigma bond, sigma bond, sigma bond, sigma, 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 and this sigma. Always single bond forms sigma bond. So this is an orbital picture diagram, you should know. And if I talk about the method of preparation, this is short form I have written on here. Means preparation, full form you should understood. So if I talk about the Woods reaction is just like this. If I treated alkyl haloalkanes with sodium metal, these are haloalkanes are those compounds which are formed by the halogen group and alkane group. So haloalkane CH3Br plus sodium metal plus BrCH in the presence of dry ether, we will get ethane, because 2NaBr sodium halide will remove from here just like 2NaBr. Sorry for that, I have just written by mistakenly Cl but Br. If it is a Cl, then we'll write Cl on here. So if I take a Br, so I will obviously write Br. So this is a byproduct and this is a main product. So this method used to form higher alkanes. Next is very simple method, combustion method. If we oh sorry, I have just written combustion method. In this way we will get the formula just like this. So I've just written by mistakenly, for sorry for that, and you should have remember only this kind of preparation. And this is the combustion method is not too important, but you can remember it like this. So this is the basic methods of preparation I have discussed. So many preparation can be for the examination in the alkanes, but you should know a very few for the basic understanding of the alkanes. So I think you should have an understanding about this concept of this group alkanes. In next lecture we will discuss about the alkenes.